Students, in the last episode, I have discussed one part of electrostatics, that is field, potential, Gauss theorem, etc. Now, I am taking the second part of electrostatics, namely capacitors. I would like to tell you that in electrostatics, normally you will get 4 or 5 questions. 2 may be from field and potential, another 2 or 3 may be from capacitors. Therefore, the study of capacitors is very important from the CET point of view. Let me now take up. The first question is, a parallel plate condenser is charged and is disconnected from the battery. If the plates of the capacitor are moved farther apart by insulating handles, A. Charge becomes 0, B. Capacitance becomes infinite, C. Charge and capacitance increase, the voltage across the plates increases. I request you to please note, suppose this is a capacitor. If you want to charge it, it should be connected to the terminals of the battery as shown here. When you connect it to the terminals of the battery, condenser will be completely charged to its full capacity. He says, now after the condenser is fully charged, it is disconnected from the battery. Therefore, assume that it is disconnected from the battery. Then you can easily note that the charge on the capacitor will become constant. It does not change because it has already been charged to its full capacity. Now, by the insulating handles, if you pull the plates apart, you know that capacity is given by the formula C is equal to epsilon 0 into A divided by D. Therefore, when D increases, capacity decreases. You can agree that the charge on the condenser will not change. Consider Q is equal to C multiplied by V. As I mentioned, charge on the condenser remains constant, but the capacity decreases. On account of that reason, the potential difference between the plates must increase. Hence, the right option is D, that is, voltage across the plates increases. I want to give another additional information along with the same question. Suppose in the question he had not told you that the capacitor is disconnected from the battery. Suppose it is told that battery connection is maintained and the plates of the condenser are pulled apart by insulating handles. Then what would have been the correct answer? Note, in this case, since it is connected to the battery, depending on the capacity, the charge will either flow from the capacity to the battery or from the battery to the capacitor. Note the formula Q is equal to C into V. Since condenser is connected to the battery, potential difference across the plates of the condenser remains the same, but the capacity has decreased. Consequently, charge should decrease. If the charge on the capacitor decreases, then the charge will be rejected from the capacitor and it will be transferred to the battery. Therefore, if that was the question, the option would have been charge flows from the capacity to the battery will be one of the options, and that is the correct answer. Hence, the correct option to this question is D. Next two questions are very important from the concept point of view. I request you to please note the concept carefully. Now, I will take the next question. The parallel plate capacitor with air as medium has the capacitance 10 microfarad. The area of the capacitor is divided into two equal hollows and filled with two media having the dielectric constant K1 equal to 2, K2 equal to 4. The capacitance of the system will now be in microfarad, A 10 microfarad, B 20, C 30, D 40. Consider a parallel plate capacitor with air as the dielectric. He says the capacitance of this capacitor is 10 microfarad. Suppose it is divided into two hollows with one half filled with a dielectric medium of a dielectric constant equal to 2 and the other one filled by a dielectric medium with a dielectric constant equal to 4. Please note that if you divide it into two equal hollows, area of each capacitor becomes half of the original area. You know that capacity is given by the formula epsilon 0 A divided by D. Therefore, when the area is hollowed, capacity is hollowed. Therefore, before the dielectric being placed, capacity of this condenser or this part of the condenser is 5 microfarad. 10 divided by 2 is equal to 5. If you now fill it with a dielectric material of the dielectric constant 2, capacity increases K times, means 5 into 2 is equal to 10. The second half also with the air medium had the capacity 5 microfarad, but you have filled it with the dielectric material of the dielectric constant 4. Therefore, capacity of the second part becomes 5 into 4 equal to 20. Now note that similarly charged plates are connected together, and that is the criterion for parallel connection. On account of that reason, these two capacitors should be assumed to be connected in parallel. If it is connected in parallel, then you can agree that this is a 10 microfarad, this is 20 microfarad, 10 plus 20 will make it 30 microfarad. Therefore, the option number C would be a correct answer. In this question, to make it a little more clear, let us now take up a next question and work it more quickly. Suppose the question was, there is a parallel plate condenser with a capacity equal to 15 microfarad. It is divided into 3 equal parts, and the first part is filled by a dielectric medium of the dielectric constant 2, second one by a dielectric medium of the dielectric constant 3, third one by the dielectric medium of the dielectric constant 4. Since area becomes 1/3, capacity also becomes 1/3. Therefore, if air was the medium, the capacity would have been 5 microfarad. When you fill it with K1 equal to 2, 5 into 2 equal to 10. The second one, 5 into 3 equal to 15. 15 plus 10 is 25. 5 into 4 equal to 20. 25 plus 20 equal to 45. Therefore, capacity of this condenser would now become 45 microfarad. Please note that if the dielectrics are so placed such that the division is vertical, then the individual capacitors should be taken to be connected in parallel. Therefore, the correct option is C.